Hi, my name is Sophie. I'm a Scottish 6th year high school student who's been researching the history of forensic entomology since September 2020, and this video acts as a presentation of my research. Here I will cover a brief introduction to forensic entomology, a more in-depth introduction to its history, especially pre-1920s, 2 true crime medico-legal cases where insect evidence proved vital, and I'm also going to be talking about 5 contemporary scientists in the field. My sources and some documentaries are linked in the description of this video if you're hoping to learn more. And if you have any questions, feedback, and/or other cool insect evidence-based cases, don't hesitate to leave a comment. So, to begin, what is forensic entomology? Well, forensic means relating to criminal investigations, and entomology is the study of insects. Thusly, forensic entomology is the study of insects which are relevant to forensic investigations. There are 3 subfields, that's urban, stored product, and medico-legal, what I'll be talking about here. The medico-legal subfield looks at arthropod evidence in murder cases and other crimes. This evidence allows scientists to estimate the time elapsed since death occurred, also known as the post-mortem interval or the PMI. This is always an estimate and can only be as accurate as a window of time. A case we'll look at later was thrown wildly off course by a scientist who claimed to have certainty of a very specific window of time when he did not. Insect evidence also helps to figure out whether a body was moved or tampered with in any way after death. Insects are drawn to open wounds in parts of the body which are easily accessible. Certain insects are only active in specific geographical locations and at specific times of year, and this can allow scientists to connect the presence of some insects to other events, which can strengthen or disprove people's alibis. Entomological evidence is rarely used in court, but more as an intelligence tool. However, this depends on the other evidence available in a case. There are also several confounding variables which can influence insect development times, such as ambient surrounding temperature, weather, and the pH of salt water. Scientists must control for this, or they risk calculating an incorrect PMI. Another case we'll look at features an entomologist who controlled for specific conditions by recreating them and observing changes. Now on to some of the techniques used by forensic entomologists. Here we'll take a closer look at the use of successional waves of insects. A human body supports a very rapidly changing ecosystem, moving from the fresh state to dry bones. Different stages of decomposition are attracted to different types of insect over the weeks or months until skeletonization is complete. The first species to appear are the Californidae, or blowflies, and the Sarcophagidae, flesh flies. They can appear within 24 hours of death or within minutes when blood or other fluids are present. Basically, they're looking to lay their eggs, and in order to increase the chances of their young surviving, they want somewhere relatively warm, moist, and surrounded by food. In some situations, colonization may be delayed by burial or covering of the body, which can affect the PMI estimate, but in most cases, observing these flies gives the most accurate PMI. Carrion beetles show up at a later stage of decomposition, specifically the dry stage. A wide variety of insects are involved at each decomposition stage, including species which arrive to feed on other insects and not the body, and each species' feeding period overlaps with those adjacent to it somewhat. Therefore, professional knowledge can be applied to analysing the insect assemblage associated with the remains, which can then be used to estimate PMI or figure out other specifics of the person's death. And here's the other technique I focused on, the use of maggot age and development. This can give a date of death accurate to a day or less and can be used in the first couple weeks after death. Maggot here refers to the immature stage or baby of Diptera, that's the family of toe-winged flies. The most used insect for this method, and therefore one of the most important insects to a forensic entomologist, is a blowfly, that's the Californidae from before. They're used because they're the first insect to arrive on the scene, and their development follows a well-documented and predictable cycle. Stages of larva development can be separated into instars, each separated by a molt, when the maggot sheds its exoskeleton, like a snake shedding its skin. Firstly, insect eggs are laid by adult flies on the corpse, and later hatch into first instar larvae. They feed on the body and develop into second and then third instar larvae, which feed a little longer, then wander away from the corpse, either into the clothes or the earth, to settle down and pupate, going through a number of other stages as it metamorphoses into an adult fly. After the adult fly has emerged, it repeats the cycle. Each of these stages takes a set, known period of time, which is affected by a number of confounding variables, such as food availability and ambient temperature. These are pretty much directly proportional to rate of development. This method's only effective for determining the stage of development for the first generation of flies. After the first adults have begun to emerge, it loses its efficacy as it becomes impossible to determine which generation is present, and so the successional waves of arthropods are used instead. Now onto the history of forensic entomology, from the 13th century to the present. So, at the very beginning of the timeline, Song Si, a Chinese medical doctor, published the textbook which contained the very first documented case involving insect evidence in a murder investigation. It's pretty big stuff for the 13th century. When a murder was committed using a scythe as a weapon, every field worker was gathered in the village square, where they were told to lay out their farming tools. It was a hot day, and within minutes a black cloud of flies had swarmed the guilty man's weapon. They were only feeding on the trace amounts of blood on the blade, but it was a pretty ominous sight, and it prompted him to confess where he stood. Pretty dramatic. Anyway, Songsi was way ahead of the curve, as it was another 4 centuries until any notable discoveries were made again. But artwork such as these woodcuts from the 15th century represented insect inhabitants of corpses. The next notable discovery was made by Francesco Redi, an Italian physician. He disproved the theory of spontaneous generation. At the time, it was thought that maggots spontaneously arose from rotting meat, as basically nothing was known about insect life cycles. His experiment involved 3 jars of meat, one completely open to the air, one sealed with cork, and one covered with gauze. He found that maggots only arose from the fully uncovered jar, and that when he kept the maggots and waited for them to metamorphose, they would become flies. Things sped up from there. The next notable discovery was made in 1831 by Matthew Orfila, the father of toxicology, who observed that maggots play an important role in decomposition. And in 1855, Bergeret d'Arbois gave the first modern forensic entomology report, to include an estimation of PMI. Then things were quiet for a few years until 1881, when German physician/entomologist Hermann Reinhard and Austrian physician Eduard von Hoffmann performed forensic entomology's first systematic study. They collected various arthropods from exhumed bodies and took notes. Together, they're thought of as the founders of forensic entomology. In 1894, after 16 years of research and fieldwork, French entomologist Jean-Pierre Mignon published La Faune de Cadavres. This is the first in-depth book written with a focus on forensic entomology, and his work greatly advanced the science as well as bringing it to the public eye. It contains illustrations to assist in the identification of larval and adult forms for a number of insect families, with a focus on those relevant to forensic entomology. It also contains his theory of successional waves of insect inhabitants and 19 case reports from his fieldwork. In 1900, Polish medical examiner Edward Ritter von Niezobatowski provided experimental evidence that humans and animals share the same types of fauna during the decomposition process. And in 1907, English entomologist Klaus Morley published an article which definitively classed Necrophorus vespillo as carrion beetles. During the 1920s, scientists carried on Mignon's work by publishing various species lists of forensically relevant species of arthropods. And there's a gap in research for decades after this due to World War II and the effect it had on the world. Research was maintained in the 1930s through the 1980s primarily due to the work of Marcel Leclerc, a Belgian medical doctor, and Pekka Nuorteva, a Finnish biologist. In the years leading up to the 1990s in America, interest in the field was building once more, and in 1996 the American Board of Forensic Entomology was formed. From then through the present day, forensic entomology is being systematically researched and investigated as a feasible source of evidence in legal cases all over the world. And as with any field of science, there is still so little that people know with certainty, and any number of discoveries are on the horizon. Alright, here's the first of the true crime cases we'll be looking at. I'll warn ahead that these cases are both upsetting and graphic, and it's okay to skip ahead if you need to. There's timestamps in the description of the video. Case 1. The murder of Lynn Harper. In 1959, 14-year-old Stephen Truscott was wrongfully imprisoned for the rape and murder of his 12-year-old classmate, Lynn Harper. On June 9th, he had been the last identified person to see her alive when he gave her a bike ride around 7 p.m. before meeting his friends in the park at 8. The case built against him was based almost entirely on vague eyewitness testimonies and one unscientific lab report. The lead forensic scientist had been coerced by the police to make things easy for them after naming Stephen Truscott as the primary suspect. Measuring the level of digestion of her stomach contents, which current-day scientists say is a technique of no scientific credibility, he claimed she had to have died between 7:15 and 7:45 p.m., the exact period of time for which Truscott had no alibi, as he had been travelling to see his friends by himself. On December 8th, Stephen Truscott was found guilty and sentenced to death by hanging. This was commuted to life imprisonment in early 1960, and he was released in October 1969 when he was first eligible for parole. In 2006, forensic entomologist Gail S. Anderson re-examined insect evidence which had been collected from Lynn's body in 1959, but never admitted in court due to the limited knowledge of forensic entomology at the time. Anderson found that insect colonization had not occurred until June 10th, which would have agreed with the coroner's report that was given at the time and dismissed. Truscott had a rock-solid alibi for the time window she predicted Lynn Harper died in, as he had been in school being questioned by a police officer after her parents had reported her disappearance. Gail S. Anderson brought this to court, and in 2007, after 48 years falsely accused, Stephen Truscott was acquitted of the charge of murder. So, that was a case where insect evidence was used to prove someone didn't do it. Here's a case where it was used to prove someone did. The murder of Roxanne Tandal. In late December 1989, She was reported missing by her co-workers, who were concerned that she hadn't turned up to work after a fight with her husband, Benjamin Tandell, who she had been very close to divorcing. On New Year's Eve, a search party found her body, which had been wrapped in 2 blankets, tied up and hidden in a forest. The police had reason to suspect Benjamin Tandell, who had been the last person to see Roxanne 13 days prior, and they called in forensic entomologist Lee Goff to help interpret insect evidence found on the body. Goff found that insect assemblage suggested that Roxanne had only been dead for 10.5 days, but he suspected that the body being wrapped had affected the time taken for flies to come into contact with it. He experimented by replicating the wrappings around a pig carcass and observed it in his back garden. In his words, the dogs loved it, but the neighbours stopped talking to him for a while. His hypothesis had been correct. The blankets delayed the insect inhabitants by 2.5 days, and he was able to confirm that Roxanne had been dead for 13 days, which, combined with other testimonies and forensic evidence, meant that Benjamin Tandell was found guilty and convicted. So, now you've learned what forensic entomology is, how it came to be, and how it can be used in legal cases. Who uses this stuff, I hear you ask? Which is a fair question. You've heard about notable forensic entomologists of the past. What about notable forensic entomologists of the now? Okay, well, I'll start with Dr. Lee Goff from Roxanne Tandell's case. He's been a forensic entomologist since 1983, and if you're a fan of crime dramas, that case might have seemed familiar to you. He's the forensic entomology consultant for the TV dramas CSI and Bones, and often cases he's worked end up as plotlines there. He's also the curator for a travelling museum exhibition, and in the years since he started work, he's been consulted for more than 300 cases. Next, here's Dr. Neil Haskell. He's very cool. He became America's first full-time forensic entomologist gradually over the 1970s. He's worked on over 500 cases. And, this was a crucial fact to include, he drives a van with the license plate Maggot. Moving on, this is Dr. Gail S. Anderson. She was Canada's first full-time forensic entomologist, starting work in 1992, and she's the person who was asked to re-examine the insect evidence from Lynn Harper and Stephen Truscott's case. Before starting work as a forensic entomologist, she was a high school technician. Now, closer to home for me, this is Dr. Martin Hall. Basically, any forensic entomology paper to come out of the UK will have his name on it somewhere. He works for the National Museum London, and he's been a forensic entomologist since 1989 and worked over 150 cases. And finally, Dr. Amaret Whittaker, another UK forensic entomologist. She's also published many papers, including 2 books about fleas, since she began work as a forensic entomologist in 2004, and she's a research scientist focusing on the behaviour of blowflies. This was a very brief foray into the present-day world of forensic entomology, and if it interests you, I'd recommend you look further into it. Alright, as I said at the start, I've included sources for my information as well as my favourite documentaries on the subject in the description of this video. Please go ahead and leave a comment down below if you have any questions or feedback, and I hope you learned something. Thanks for watching.